here's your video solutions for the independent practice worksheet, 2 through 10 even, where I'm going to model for you how to find the volume of cones, cylinders, and spheres by following through on some very distinct steps so that you'll be able to do your own problems tomorrow. So let's go ahead to number 2. It says the water pipe has a radius of 5 centimeters and a height of 7 centimeters. What volume of water does it take to fill the pipe? So the first thing I'm going to do in all of these problems, since we're talking about shapes, is I'm going to sketch the shape. So here's my cylinder. Now I'm doing that so that I can take the information from the problem, the radius of 5 and the height of 7, and put it into the picture. It's easier to look at a picture than it is words to get information. I know radius is halfway across the circle. Diameter is the whole way, so I know that that's 5 centimeters. I know the height is from one base to another, so that's 7 centimeters. Now obviously this isn't drawn to scale. I'm just taking information from the problem and putting it into a model. Okay, next step. I need to find out what exactly I'm being asked. I'm asked the volume. So we know the formula for volume of a cylinder is pi r squared height. So I'm solving for this v, which means I have to substitute the information from the problem in for these variables. So we know pi is approximately 3.14. We know the radius is 5, so that's going to be squared. And we know my height is 7. So now we're just going to do order of operations. So I always do exponents first. So I have my 3.14 times 25, because that's 5 times 5, times 7. And then I'm just going to go left to right. So I have 3.14 times 25. So 0, 2, that's 7, 15. So that's 8, 2, 6, 0, 15, 8, 7. I have 2 decimal places, so 2 down here. So that's 78.5 times the 7. And then I'll do one more multiplication problem. Doesn't hurt you to do this by hand, but if you want to check it with a calculator, that's fine. So that's 35, 56, 59, 49, 54. 1 decimal place, so 1 down here. So I get 549.5, and our label has to be centimeters, but since I'm using 3 dimensions, okay, this is cubed because it's a 3-dimensional object. It's a solid. So we always have cubic units. In this case, it was centimeters. Okay, number 4. For Anya's birthday, her father gave out colorful birthday hats that were cone-shaped. Anya was very happy that day. The opening of the bottom of the hat was 3 centimeters, and the height of the cone was 7 centimeters. So we're making little cone hats. Okay? All right, and then their little faces would be in there. Okay? There's little Anya. She's so happy. All right, so we know that the opening at the bottom of the hat was 3. That means the whole thing was 3. So that's our diameter, 3 centimeters. Now that's pretty small, okay? So I don't know what kind of head those kids have, but that's pretty tiny. And the height of the hat was here to here. So that was 7 centimeters. So we have our information in picture. Now we write our formulas. We know the volume of a cone is either 1/3 pi r squared height, or if you'd rather write it pi r squared height divided by 3, that's okay. So we'll keep it like that. Okay, we know pi is about 3.14. We know the radius of the hat is half. So half of 3 is 1.5 squared. And then we know the height is 7. And then we're going to divide by the 3. Right, order of operation tells us that we have to again do that first. Well, I know from the unit on roots and radicals that 15 squared is 225. So 1.5 squared will be 225, but with the decimal right there. Then we'll multiply by 7, divide by 3. Okay, this problem, I'm going to go ahead and use a calculator now, because those end up being bigger numbers, and as long as I'm showing my work, that's fine. So I have 3.14 times 2.25. 3.14 times 2.25. So that equals 7.06. Then I have to multiply that by that 7. And I get 49.455. Then that's going to be divided by the 3. So don't forget that last step. So I go to my calculator again, I take the previous answer, the subtotal, and I divide by 3, and I get 16.485. Of course, remember your label is centimeters, so that would be centimeters cubed. Number 6, the guest house is in the shape of a cone. I don't know why the house is in the shape of a cone, but that's the problem. The house is 7.5 feet high and 22 feet long. Find the volume of air that occupies the house, assuming it is empty. So I'm assuming that this house, since it's in the shape of a cone and all the dimensions they gave me, looks like this. So it's lying on the ground like that. So as you walk in, I don't know, it gets smaller, so I guess you can't be too tall. So, but anyway, we know it's a cone shape. The house is 7.5 feet high and 22 feet long. So I guess the height right there, they're thinking is that. So that's 7.5. And it's 22 feet long. That's from here to here. So we'll go with that. It's not necessarily important the numbers I have in the problem. It's how I actually do the problem. So kind of a ridiculous word problem, but let's deal with it. So volume equals, a cone again is 1/3 pi r squared height, or pi r squared height divided by 3. So pi is 3.14. All right. The radius of this is from there to there. So we take 7.5 and divide it by 2. So that's going to be 3. That's 6. So there's 1 left over. It's going to be 7. That's 14. So add your 0. 1 left over. So 3.75. And that's going to be squared. Our height is 22. And our division is by 3. So remember, what I'm showing you now is simply to substitute numbers into the formula. When we do this together, I won't give you these ridiculous numbers. So I need 3.75 squared. So 3.75 times 3, get mixed up, 3.75 times 3.75. So that equals 14.0625. And then I know I have to multiply it by that 3.14. And then I have to multiply it by that 22. So I get 971.4375. 971.4375. And then I divide by that 3. So take your subtotal right there, divide by 3, and you have 323.8125. All right? So and our label is feet cubed. Now, if we go back to the original directions, it doesn't tell us to do any rounding. So if we have those directions, obviously some of these answers would not be quite as lengthy. So if I were to actually round this, I would just say 324 cubic feet. I would just take that 8 and make that 3 into a 4. But the whole idea here is if you can remember to take your problem and make a picture of it so you can put in the information, then take that information, substitute it into the formula, then follow through order of operations on the formula, then it doesn't matter what your answer is. You'll get it right no matter what. Okay, 8. A small sphere-shaped jar has an 8 centimeter radius. What is the volume of the bowl? So here's my, I'll just kind of, okay, so there's my ball. we know that the radius is 8. So this distance from the center up to an edge is 8 centimeters. What is the volume? So we know volume of a sphere is 2/3 pi r squared height, or 2 times pi r squared height divided by 3. So let's use this formula right here. So I have 2 times 3.14. Okay, the radius obviously is 8, so that's squared now. The height of a sphere is actually its diameter as well. So if you want to rewrite your formula to be 2 pi r squared times diameter divided by 3, that's fine. You're manipulating it so it best suits you. Okay, so my height would be 8, and another 8 would be 16, and then I divide by 3. All right, so let's go ahead, and I know that 8 squared is 64. I don't need a calculator for that. But now I want a calculator to do the rest. So I have 2 times 3.14 times 64 times 16. So that equals 6,430.72. And then I still have to divide by 3. So go back to my calculator, take that subtotal, divide by 3, and I get 2,143.573. 2,143.573 repeating. So let's go ahead and round that to approximately 2,140, and we'll take that 5 and make that into a 4. We know the label is centimeters, so it would be centimeters cubed. All right, and the last one. The tennis ball has a radius of 12 centimeters. Okay, that's a big tennis ball. Calculate the volume of the tennis ball. So here's my tennis ball. Okay, it has a radius of 12. So again, halfway across, 12 centimeters. So this is just like the last one. So we're going to write our formula. We're going to make it 2 pi r squared, and we'll put d for diameter this time, and then divide it by 3. So let's substitute our information from our problem. So I have 2 times pi. Okay, the radius we know is 12, so that's squared. And our diameter then would be this whole distance across. So if half of it's 12, the whole distance is 24. And then we divide by 3. So I know this could be 2 times 3.14 times 12 squared is 144 times the 24, and then divided by 3. So I'm doing a little one part at a time. Now I can go to my calculator. 2 times 3.14 times 144 times 24. Okay, that equals 21,703.68. And then I'm going to divide by 3. So that equals 7,234.56. And the label there would be in centimeters cubed if I wanted to estimate it. Probably take that 5, change that 4 then to a 5 because I have to round up. So what was important about these problems is that you read the problem correctly, you know exactly what type of shape you're dealing with, okay, cone, sphere, cylinder, that you draw the shape so you can take the information from the problem, that you write the correct formula, you substitute the numbers into the formula correctly, and then you do your calculations properly. Okay, so we'll work some more tomorrow.